Hello everybody, myself Prasant Mukhopadhyay, faculty member Electrical Engineering Department, Greater Kolkata College of Engineering and Management. So far we have covered in this power electronics and drive class, the unit 3, the converter portion, AC to DC converters. And we have covered single phase fully controlled half wave converter with resistive load, with RL load, single phase fully controlled full wave converter with resistive load and RL load, etc. And today in this class we'll discuss about some numericals on single phase full wave half control rectifiers and some alternative circuits arrangements of these converters. So and after this discussion, so you will be say whatever the say difficulties you have, that will be cleared, I think. So okay, so let us start. So if we take an example like this, draw the output voltage waveforms for a full wave semi-controlled rectifier. So to be clear, full wave semi-controlled, that is half controlled rectifier, like shown in the circuit. Actually we have discussed earlier. So we come to the circuit for the following delay angle, that is firing angle alpha equal to 0 degree, alpha equal to 45 degree and alpha equal to 90 degree. So before coming to the solutions of this problem, so let us refer to the figure say 16. Okay, so let's see the figure 16. Actually figure 16, yes, no, this is figure 16. Okay, so this is semi-controlled half wave bridge rectifier. We have two thyristors which we can control, and these are the two diodes. So basically, actually, full control bridge rectifier circuit has been replaced. This thyristor 3 and 4 is replaced by two diodes, diode 3 and diode 4. So remember this circuit very well. Okay, so this is the load. These are the two thyristors and these are the two diodes. So that's why it is semi-controlled bridge rectifier circuits. Now we have to find out the waveform. Basically, waveform for actually. Okay. We have to find out the waveform for the defined firing angle, that is alpha equal to 0, alpha equal to 45 degree and alpha equal to 90 degree. So actually first discuss the case of alpha 0 degree. That means firing angle is 0, or that means during the positive half cycle, so SCR1 and D4 are conducting. So as that is shown here. Yes, see, this is the positive half cycle. SCR, actually here this SCR1 is fired at alpha equal to 0. Okay, so that means, so this is the flow of current. Okay, this is the way. So if we actually see this alpha equal to 0, that means what should be the waveform? So alpha is 0 means it is conducted fired here. So waveform will be just a full wave rectifier circuits. Okay, so this is like this. This will be. You see that we can find or not? See, this is the case. This is alpha equal to 0. So this is the for the first half, so 0 to pi, then pi to 2 pi, then 2 pi to 3 pi. So how? So 0 to pi, so it is S shear 1, and if we say actually S shear 1 and D4, not D2 actually, D1, D2, whatever it is, if it is named as D1 and D2, so it will be actually D1 and actually this during this positive half cycle S shear 1 and D4 are conducting, and during the negative half cycle S shear 2 and D3 are conducting. So that is shown, and the output voltage waveform will be like this. Okay, so this portion, if you again go to the say the circuit diagram, so we'll find the S shear 1 and D4, resistor D4, sorry, diode D4 will be conducted when S shear 1 is fired at alpha equal to 0. So this is the waveform. So what type of waveform it is? It is actually diode bridge, full wave diode bridge basically. So it's like this. So for this positive half, so S shear 1 and D4, and for the second half S shear 2 and D3, so will be in conduction. Okay, that is so S shear 2 and D3 are conducting. So this will be the output waveform. Okay, now and see that I discuss here also. I told you. See, this is a freewheeling diode. Come here. Yes. See, it is this is the waveform. See the waveform. So alpha is 0. Okay. So S shear 1 is conducting. S shear 1 is conducting means current is flowing. Since S shear 1 is conducting, it is just like a switch. So it will be closed. So current will flow in this way. So this way. And now for the positive half voltage, so D4 is also it is also forward biased. So it will be like this. Clear? So this is like this. For the second half, so that means output voltage will be form will be like this. So it will start from here, and it will be alpha 0 to alpha equal to this pi. Okay, so that up to pi. Now at again when for the negative half, so this alpha 0, that means it will conduct it from here. So this waveform will be like this, and so on. Okay, so that is the case for alpha equal to 0. Now alpha is 45 degree. So what will happen? So if alpha is 45 degree, so in that case this it is alpha is 45 degree. So again, this actually this waveform pattern will be same, but this portion will not appear. This will be truncated. So actually, this will be the output. Okay, this will be the output actually. Clear? So this is output. So that means for this portion, S shear 1 and diode 4 are in conduction. So this is diode 4 in conduction. This is S shear 1. So voltage is impressed across diode 4. This total voltage it is forward biased. But unless and until the S shear 1 is fired, so this is not possible to current flow to this diode 4. So that's why this is the from 0 to pi diode 4 is on. Okay, but S shear 1 is on from how much? From alpha 45 degree to alpha equal to pi. Okay, so that is omega t equal to pi. Omega t equal to alpha to omega t equal to pi. Clear? So in the again for the negative half, so S shear 2 is fired when it is at pi plus alpha. Okay, so in this duration, this diode 3 is already forward biased, but unless and until S shear 2 is fired on, so current cannot flow. So that's why. So see, diode 3 is on. Okay, S shear 2 is on for this period, pi plus alpha to 2 pi. Clear? So in this way the output waveform will be like this. Okay, can you got it? So I think everybody has say understood it. So this will be the waveform. Okay. Now, any question if you have, you put this question to me. After this class, you can say contact me over say email or phone or WhatsApp, whatever will be the way you can say want to contact. So actually, this is the waveform at alpha equal to 45 degree. Then tell me, what will be the say waveform at alpha equal to 90 degree? Any so actually I think you can say jolly well give the answer. Basically this alpha equal to 90 degree waveform pattern will be same. That means it will be fired at alpha equal to 90 degree like the here. Okay, so this output waveform just will be shifted another 45 degree. Okay, like this. Okay, see, that is the case, isn't it? See, compare this two, you'll find the same thing. So for first positive half, this diode 4 is in the forward biased condition, and when at alpha equal to 90 degree, SCR1 is turned on. So output voltage will appear across the load. Basically the current is flowing through the RL load, and it will be like this. Okay, so that's I think clear your idea about how this waveform will be modified at the with the say difference of the firing angle or delay angle alpha from 0 degree, 45 degree, then 90 degree. So actually this will this is the case actually. Okay, so I think you got this answer. Okay, now we can actually suggest some alternative circuit configurations of say of this semi-controlled say diode actually semi-controlled full wave bridge rectifier circuit. So what are the alternative circuit configuration we can think about? Basically, first of all, we have to keep in mind what are the circuit we are dealing with. So basically, actually from full control to semi-control, what we have what change we have made? The change we have made only we have replaced transistor 3 and transistor 4 with 2 diodes. So diode 3 and diode 4. Okay, now how will rearrange these 4 components of 2 diodes and 2 thyristors in such a way that an alternative circuit configurations will be formed. Okay, so let us think about it. So how this arrangement can be done? So actually what we have done, we have taken one thyristor and one diode in series and across another to form the bridge another thyristors and another diode in series. So can we reshuffle this arrangement anyway? If you can, then we will definitely get an alternative circuit configuration without sacrificing the properties and the output of the circuit. What we after reshufflement, the new circuit will also deliver the same waveform like the earlier one. So we'll let us try what we are actually trying to find out some alternative circuit configurations of single phase semi-controlled bridge converter. And see, I told you that If we reshuffle, actually little bit rearrange the 2 SCR and 2 diode circuit in such a way, basically we have the 2 branches of the bridge. One actually 2 parallel branches was one thyristor and one diode in series, and in one branch, and another branch also similarly one thyristor and one diode in series. Basically we have thyristor 1 and thyristor 4 was in thyristor 1 and thyristor thyristor 1 and thyristor diode 3 was in series, and another branch was thyristor 2 and diode 4 was in series. Now rearrange. Say let us rearrange in this way: 2 thyristors in series, SCR1 and SCR2. Basically we, if we keep the subscript like similar one like earlier one, so in that case we name the 2 SCRs SCR1 and SCR3, and 2 diodes are diode 2 and diode 4. Basically we have changed SCR2 by diode 2 and SCR diode 3 by SCR3. Okay, and diode 2 positions actually same, SCR1 and diode 4. So diagonally the 2 positions have been changed. So basically diode SCR2 and diode 3 has replaced, changed their positions, and it has SCR2 is replaced with it in place of SCR2 we have put diode 2, and in place of diode 3 we have put SCR3. Okay, so in this arrangement, so we can see what the difference will get, and how the waveform will be formed. Let's see what happened. See, actually in this arrangement the freewheeling current is limited to the path that includes the 2 diodes D2 and D4 in series. Okay, so freewheeling current is limited to the path that includes the 2 diodes D2 and D4 in series. Therefore the period of conduction for the diode increases, and that of SCRs decreases. Okay, so conduction period for diode increases, and that of SCRs will decrease. So this is the basic operational difference, otherwise everything will be same. So depending on this arrangement, if we ask you to solve some certain quizzes, so we can give you the we can say I'm giving you this quiz. So first of all, first quiz is try to draw the complete waveforms like earlier ones we have discussed, and the formulas of the average and RMS values of the output voltage, output current, supply current, and thyristor current and diode current. So everything we have discussed with the earlier arrangement of semi-controlled based converter circuit. So what basic changes has been happened. So with that changes, that is diodes will be in conduction for more time, rather thyristors conduction time will be decreases. And with this concept, the waveform will little bit modified, and of course otherwise everything will be will remain same, but calculations will also say actual value, actually theoretical value will not be but so much, but whenever we give some numerical, so say alpha is certain degrees, 30 degree or 40 degree, whatever it is. In that case, the variations of the output current, voltage, supply current, thyristor current, that will be predominant. And second quiz is find the output power, PIV, and input power factor. So how we will find all these things, output power, PIV, and input power factor, that also we have discussed. So how we will get the output power. So this is nothing but the output voltage and output current product. And so peak inverse voltage you also know, and the input power factor also is output power, so P by S actually, output power divided by the input Vs Is actually. Okay, so of course the RMS value. So actually you have to taken into consideration all these things, and you will say do these problems at your own and submit with the result. Okay, and another possible arrangement also of semi-controlled bridge converter can also be done. So what possible arrangement can be done? Well, this is something different actually. Here AC input voltage is rectified by diode bridge to give full voltage output, and then output is controlled by SCR. Okay, so basically rectification part is done by the uncontrolled diode bridge rectifiers, full output voltage output we are getting, and then it is controlled by SCR. So in that case the prevailing diode allows the flow of current through the load during the time the SCR off. Okay, unless and until the SCR is off, so prevailing diode will not mean say conduction, and the average output voltage is the same as that in case of the full bridge fully controlled with prevailing diode. So let us see how is the circuit. So this is the circuit. Okay, so this is actually bridge diode bridge rectifier, so which will give you the full rectified voltage, and then when SCR is fired, then only this is flow to this load. Okay, and when SCR is off, so this it will be say prevailing diode will be forward biased and it will be negative. Actually this is SCR will be off, this will be a negative voltage interest on this. So this will be the load current will flow in this prevailing diode. Okay, so this is the basic arrangement and a possible arrangement of semi-controlled bridge converter. So now I will give you the quiz. Let me quiz is like this. Questions, so whatever you say. Try to draw the complete waveforms and formulas of the average and RMS values of the output voltage, output current, supply current, the thyristor current, and the diode current, and the prevailing diode current. See, if you go through the classes of this single phase half wave and full wave converter circuits, what we have discussed so far, so you will definitely give the answers of these questions. So nothing new out of it. So basically you have to draw the total complete waveform, so that is input voltage to output voltage, output current, then average, and also you have to find out the formulas for the not only that, whenever you find out the complete waveforms, you have to give the output voltage waveforms, output current waveform, say prevailing diode waveform, the thyristor one thyristors say voltage, current, then diode for every diode, so that is diode 1, 2, 3, 4, so their current profiles, etc., and then also prevailing diodes. And then you have to find out this average and RMS values of the output voltage, then output current, supply current, thyristor current, diode current, and freewheeling diode. So that's what I am telling. So actually from the waveform, and basically whenever you will able to form the waveforms, and you can usually write down the mathematical expressions of these different values. That is VO, IO, IS, ITH, ID, and FWD, etc. And you will calculate it. Just not a very big deal of it. And then also again it's the same question. Find out power, output power, PIV, and input power vectors. So that's also we have discussed. Okay, just only the modifications of the circuit diagram. And discuss the case if the load is inductive load in series with EMF. That means you have to discuss the case. So when this RLE load, in case of RLE load, so this effect of say EMF in series with this load, so will definitely modify the waveforms. Okay, that you have to consider, and accordingly you have to draw the waveform. Clear? So if you try out these questions of your own, so it will actually clear your understanding, and I think in future you won't get any problem with this single phase say converter, actually AC to DC controlled rectifier circuits. So whether it is say half wave, whether it is full wave, whether it is half control, whether it is full control, whether it is center tap, whether it is bridge type, whether it is resistive load, whether it is resistive inductive load of say low inductance value or high inductance value, and again whether it is RL load with freewheeling diode, or it is RLE load and freewheeling diodes, etc. Okay, so with this we'll definitely complete our discussions on this particular say semi single phase converter circuits, half wave, full wave, both. And next class onwards we'll discuss the same things of in case of three phase say AC DC converter circuits, so with say different type of load, resistive, inductive, along with the freewheeling diodes, and with say RLE load, whatever it is be the case. And in the same way we'll take and say go forward our discussions on three phase converter circuits. So with this we may conclude our discussions. And I told you earlier also, and I have taken the help of the textbook, mainly Rashid, Power Electronics, and then PS Bhimla, and then Singh Kanchandani, and different say websites, different NPTEL course materials, and others also. So I hope you will enjoy these discussions, and if you find any problem, I told you repeatedly earlier classes also, and today also I am telling that in case of any problem, don't hesitate to contact me over phone, over WhatsApp, or my mail ID. That everything I have shared with you in the very beginning of this subject. And say if we talk about the outcome, so after this you will be able to say at your own this AC to DC converter circuits. That's all. Thank you.